Make sure everybody at home clicks the little acceptance button.
So we'll see how many people we get.
Very good.
It'll be interesting.
Ron should be here. You mentioned that last night.
Yep.
Watching.
Well, we opened up the window a little bit early tonight, so we've got still about 6 minutes to go, Steve. So before we officially start TennaTalk. Which means I'm way ahead on my run of show.
So, John, just to put this in context, TennaTalk started back in the beginning of the year when I started producing monthly seminars, TennaTalk seminars, doing a presentation, and then we separated out the Q&A portion to a monthly live TennaTalk on Zoom. So that's what this month's TennaTalk is all about. Live is not a follow-up this month, but rather you are the featured speaker and the guest extraordinaire. And so that's how we came to be here today. So we have a whole series of these TennaTalks, both presentation as well as Q&As up on my website, or excuse me, my YouTube channel.
Well,
that's quite interesting.
Everybody can see it coming in for you. And I have spotlighted all of you. So if everybody is in gallery mode, they'll be able to see you on their right side of their screen. And of course, everybody is a Zoom expert around here, so they can manipulate all their views they wish.
So, Charlie, I assume we're going to start on time.
Well, we could start early, but
No.
we might, we do have some people that have not checked in yet that have said they will be coming. So
right. Let's give it to the top of the hour.
Got it.
Oh, Charlie, I saw they got a new version of that RS 918 one that you and I have. It looks completely different. They're selling it for like $600. I'm not sure what the difference really is, but it's
Probably not much, but they do change the location and the colors and everything of the knobs that are on it.
Yeah, it's quite a bit different.
That's one of their tricks.
Yeah, I guess so.
I call that the Baofeng trick.
Yeah.
Because if you take a case and remove all the electronics from it, you can put it in any other case, and that's what they do.
Yeah.
They do add a few things once in a while, but
for $250 more, I don't know.
Oh, that's probably because they discovered that they can charge us $50 more.
No, $250.
Oh, 250.
Yeah,
oh, that's ridiculous.
Wow.
I haven't seen that price. So did you see that on the Chinese side or on the American side?
Well, eBay as well as AliExpress, they're both selling it. It must have come out just within the last couple of days because it's a totally different look to it. And the screen looks the same, the display looks the same, but the packaging is very different.
Mm-hmm. Yeah, that can happen. Oh, Frank Kostelak has joined us. Good. Welcome, Frank.
T-minus 1 minute and counting.
Yeah, actually about 33 seconds. There we go. There. Okay, people will be automatically joined in. We do have the gallery is open, and they will be able to join the meeting directly. So welcome everybody to TennaTalk. It's the August 7th, 2023. I almost said 1923. That would have been strange for 2023. And just so you know, we have a special guest tonight, John Portune, W6NBC. If you've got the note, you'll know what this is about. Slot antennas for ham radio. And on that note, of course, TennaTalk is a production of the Atana Winspur. That's Rudy Wiedemann, K7RAW, and it is sponsored and supported by the Las Vegas Radio Amateur Club here in Las Vegas, Nevada. So on that note, Rudy, I'm going to turn it over to you, and I will take this share screen off and let you introduce our special guest. Go ahead,
Oh,
Rudy.
great. Thanks, Charlie. So for this month's TennaTalk, we're doing something a little different. And I was able to connect with John, fortunately. John is a published author. He has at least one book that I saw and I bought and read with great delight on slot antennas. He's done a number of presentations on slot antennas and, as it turns out, many other antenna topics. So naturally, I was intrigued and interested. So I contacted him and we chatted about slot antennas, and then I asked him if he'd like to do a presentation for the club. So here he is. So without further ado, let me introduce John Portune, W6NBC, on slot antennas for ham radio. Take it away, John.
Well, good evening to all of you, and thank you for having me. Slot antennas has been an interesting topic for me because when I worked for KNBC Los Angeles, which I did for quite a number of years, I became aware of slot antennas because in those days, slot antennas were the principal form of antenna used in the television broadcasting industry, as we'll see here in a minute. And but like many hams, I knew of the slot antenna, but never understood how they worked. And so it's how I got interested in them. But let's go ahead and look at this presentation. I'm going to open this PowerPoint up here. This is a PowerPoint I haven't showed in quite a while, so we may add a few things to it as we go along. This was originally presented some time ago at the first QSO Today Expo, and with some interesting results. Slot antennas for ham radio, and it also spun off a book, which you can certainly still obtain by going to Amazon.com and just searching on this title, Slot Antennas for Ham Radio, and it's a Kindle ebook, which you can download for a modest price. Slot antennas.
John, did you want to share your screen? Because we're not seeing it yet.
Oh my, beg your pardon. Haven't done that. Okay.
Yeah,
Why haven't we done that?
Click share screen, hit the.
Yeah, I know how to do it.
Good.
Let's see, share.
Okay, I think it's coming up now. Okay, we've got your full screen on there.
Slot antennas for ham radio. Now are you slide show from the beginning? Now are you seeing the opening slide?
I've got an undiscovered country in ham radio.
Okay, slot antennas. This is an antenna that most hams know the name, but they really don't know what in the heck it is. And so it is a la the Enterprise here going off into a distant planet. It is, and the name of the movie that came out by that title, more or less undiscovered country for hams. they don't really know what this particular type of an antenna is. And like I said, when I was working at NBC Los Angeles and knowing that antennas for ham for TV broadcasting were mostly slot antennas, big circular, big tubular antennas that sat up on most mountaintops with slots cut in the side of them. I didn't know how they worked. They were a mystery to me, and as I think they were to most hams. So they are pretty much undiscovered country. They were introduced to the television world by this very British-looking engineer, Alan Blumlein, in 1938, who was working for EMI Broadcasting in England. He pointed out that the slot antenna, and by the way, this picture that you see on the right is the big tower that sits on top of Twin Peaks in San Francisco, for which the TV show was named. Still, the mountain is called Twin Peaks. It's got 2 bumps on it. This is the big Sutro Tower, named after one of the founders of San Francisco. And on top of it, you'll see 3 great big slot antennas. They're great big tubular waveguides. And on top of them, these were the 3 big broadcast slot antennas, TV slot antennas. They're broadcasting all over the San Francisco Bay Area. And television broadcasting was dominated by slot antennas. In fact, it still is. Even UHF broadcasting is still largely done with slot antennas because of a characteristic of this antenna. They are vertical antennas, but that are horizontally polarized, which is a unique quality of the slot antenna, that the polarization of the slot antenna is at 90 degrees to its vertical physical structure. So these verticals, although they have the radiation pattern of a vertical, which is omnidirectional, their polarization is vertical, which is very interesting. Or if it was a horizontal slot, it would be vertically polarized. So that's why the slot was shown by Blumlein to be ideal for television broadcasting, which has in the United States and largely in the UK at the time, was horizontally polarized. Well, slot antennas haven't gained a lot of popularity, particularly among hams. They've gained popularity in other ways. You see here, they have gained popularity in the microwave world, where you see here a panel antenna with a lot of slots cut in it. And this is a plain panel slot antenna with a whole bunch of slots. Yeah, UHF, it'd be SHF slots in it. The Concorde, when it was still flying, had a number of slot antennas cut into the tail of it. So, but in 1938, when slots were introduced, hams were not interested in VHF antennas. They were interested in HF. So it's not surprising that slot antennas never gained much popularity in the ham world. But one day, I was wandering, driving down the street, and I happened to see a couple of these direct television broadcasting or satellite broadcasting dish sitting up on a housetop here, a dish or a direct TV dish. And it occurred to me, wouldn't it be great if I could hide my 2-meter base station antenna in one of these satellite dishes? Because I live in a homeowners association restricted home. In fact, I live in a mobile home, and then the Gestapo, who comes wandering around doing their annual checks on our homes, for antennas and other things, because we're not permitted to have antennas of any sort on our mobile homes. Of course, I have several of them, well disguised, so they don't know what they are. I thought, wouldn't it be great if I could hide my 2-meter antenna in one of these dishes? But then I thought, so could I hide my 2-meter base station antenna in a TV satellite dish? Thought that would be great. My CC&R committee wouldn't make me take it down because, of course, the FCC regulation, this one, says that you have to allow satellite dishes. We all know about this one. This is why satellite dishes are permitted everywhere, even with CC&R regulations. But I got to thinking, wait a minute, it'd be pretty difficult to put a 2-meter antenna up on my satellite dish. Wouldn't all that metal compromise a 2-meter antenna? And indeed, it probably would. how could I get around the fact that the TV dish was hardly an ideal place to put a 2-meter antenna? I thought, well, no, wait a minute. Don't fight with the metal. Cut a slot antenna in the reflector of the dish. And that's what I did. Now, this picture here you see on the left is the direct TV dish that still sits on the back of my house to this day. If you go out to the back of my house, you'll find this very same dish. The birds have decorated it a little bit ever since. But you can barely see the slot antenna cut into it. It's not very visible, and the neighbors don't see it. Neighbors don't see it at all. It's completely invisible to the neighbors. When I wrote the book, which you can see it there on the right, I kind of emphasized the slot by using Photoshop to make it a little bit bigger. It's really not that big cut into the dish, and it doesn't have to be that big, but I made it for the cover of the book look a little bit huskier so you could see it a bit better. And that's the cover of the Kindle ebook, which you can get off of Amazon.com if you want to read about slot antennas. And this article got published in QST April 2016, which you can get from my website if you want, just by going to W6NBC.com/articles, and you can download that article if you want. And by the way, you can download any of my PowerPoint presentations there too, by also going to W6NBC.com and put slides, W6NBC.com/slides, and any of my PowerPoint slides will come down to you. You don't have to remember anything you see in this presentation, because you can get all these slides for yourself and distribute them as you wish. I don't mind. A lot of them have gotten put up on YouTube. So April 2016 has this article in it showing you how to do this, put this slot into a satellite antenna. And here's a picture of it. This is the reflector of a direct TV dish, or the common slimline dish, which is the common direct TV, direct satellite broadcasting dish. And and you can see the slot cut into it. It's just the slot is just the width of a single saber's or a jigsaw blade cut in the dish. And it's 38 inches long, which is the halfway length of a slot cut into that dish. It's 24 inches at the top and 7 inches drooped at the ends. It's not quite big enough for a straight slot, but as you know, you can droop the ends of a dipole and it works fine, because the slot is just the same length as a dipole. And it's just a single width of the saw blade cut. I was able to cut it quite easily on the back of my DirecTV dish. But because of the rotation of the polarization of a slot, it's vertically polarized, and that's exactly what you need for working repeaters. So this slot cut in the back plane of the TV dish radiates just like a horizontal dipole, has the same radiation pattern as a horizontal dipole, except that it's vertically polarized, and that's exactly what you want. So you aim this dish at the repeater, and it's vertically polarized and works absolutely slickly. Of course, don't try to use it for direct TV broadcasting as well, because the two of them will interfere with each other, and it'll probably burn out your TV receiver anyway. So put up a separate one of these if you're going to use it as a 2-meter antenna. You can also use it as a 440 antenna. I'll show you how to do that later on here. So there's a slot antenna cut into the DirecTV reflector. But I wanted to know more about slot antennas when I did this. I kind of did this at a lark, and it worked fine. I was surprised how well I was able to get that to work. It's the first time I ever made a successful slot antenna, and I was quite happy by just cutting that slot in that DirecTV dish. So I wanted to grok antennas. Anybody recognize the word grok, G-R-O-K? If you're a reader of sci-fi, you will recognize it, because you've probably read the famous Robert Heinlein sci-fi book called "A Stranger in a Strange Land" by the human that was born on Mars. and was trained by brought up by a bunch of Martians, and the Martians like to grok everything. In Martian, grok means to really understand things. So I wanted to grok slots. So here's me with my MFJ antenna analyzer and a little probe that I made with a couple of pins in the end of it, so I could study slot antennas. And here's me. I made a slot antenna out of some aluminum foil tape on some cardboard, some typical box cardboard. And I was studying slot antennas in the early days to see how they worked. So I was easily able to make myself a slot antenna here on some box cardboard, so I could study it with my MFJ analyzer and a little probe, which was just a couple of sharpened H632 brass screws with the ends sharpened, so I could go probing along the slot antenna there and studying it with my MFJ analyzer. And I had 5 big discoveries to make about slots, which I'm going to show you here. My first discovery, that there are very few restrictions on the plane width and the slot width of a slot. Now, a slot basically is a metal plane with a hole in it, a slotted hole in it. Of course, that's what most of you think when you think about a slot antenna. It's a big sheet of metal with a narrow slot cut in it. That's what you think of as a slot antenna. And that's indeed what a classical slot antenna is. That's a metal plane with a narrow opening in it, a narrow rectangular opening in it. That's the classical slot. But believe me, that's not the only configuration a slot can take up, as I'm going to show you here. In fact, that was my first discovery when I started studying slot antennas, that you can make the slot almost any shape you wanted, almost any size you wanted, and you can make the plane, the metal surface, almost any shape and size you wanted. There are really are no restrictions on the shape and the size of the slot and the shape and the size of the metal plane. It can vary very widely. And that was the first discovery I had to make about slot antennas. And if you're going to be a slot designer, that's the first thing you need to know about slots. They aren't all narrow. They aren't all long. They aren't all straight. They don't all have to be rectangular. Slots can vary very tremendously, and they still make great antennas. Now, I went to the radio Bibles to try to figure out how slots should be made and built. And I've got a whole bookcase full of books over there. I've got all the Bibles, the radio Bibles, Jansky and Terman and all of the big radio Bibles. I've made a collection of the famous radio handbooks, including the ARRL handbooks and so forth, which I've written several articles for, by the way. This is from Terman, which is one of the big radio Bibles. And this is the illustrations that's in Terman about what a slot antenna looks like. And when I opened it up, I thought, oh, well, if Terman put it in his book, this is how you make a slot. This is what it's got to be. Because if Terman puts it in his book, then you got to follow it, because he's a guru on antennas. So I figured if you make a slot, this is how you have to make it. You got to make it up. The plane has to be 3/4 of a wavelength long. It's got to be half a wavelength high. And the slot has to be half a wavelength long. And it got to be long and narrow like that. Wrong. It doesn't have to be any of these dimensions. This is just suggestion. Now, he's right when he says that the polarization is at right angles to the slot. That's correct, but that's the only thing that's correct about this diagram. The slot doesn't have to be in a plane of that size. That's just a suggestion. That plane doesn't have to be a wavelength wide and 3/4 of a wavelength long. It can be any size. It can be any width, and that's what I discovered with my MFJ analyzer and my aluminum foil tape on the box cardboard. In fact, a good friend of mine, KJ6THU, his name's Grant, he made a perfectly functional slot out of 2 pieces of 1/2-inch copper pipe, shorted at the ends. This is an entirely functional slot antenna. It's only got a slot that's a 1/16 of an inch wide and the metal plane is only 2 pieces of 1/2-inch copper pipe, but that made a perfectly functional slot antenna. And you can see it's fed down there at the end, where you can see the little choke and the feed at the end, and it's vertically polarized. But now the second discovery I had to make, and this was the really big discovery. You might be asking yourself, how in the heck can a hole in a big metal sheet be an antenna? How does a hole radiate like a dipole? I pondered at this for years. I didn't know how that could possibly be true, because how does a hole act like an antenna? I didn't understand this until I finally did understand it and finally came to know how it works. Okay, here's a common explanation that you'll find in almost any of the radio books that you look into, which, by the way, do not explain how a slot antenna works. I am sorry, I've got all the radio books, all the big Bibles on radio, including the ARRL handbook, which, by the way, I've got a new article in it, which does explain it. I got together with Ward Silver, and we wrote a new article for the new handbook that just came out this year. And the article in it is right now. It explains how a slot works properly. But here's a common explanation you find in the handbooks. They say it's a big metal plane with a slot cut in it, and it's the equivalent of a dipole. You see the dipole at the top, and you see the slot at the bottom, and they say they're the equivalent of each other. And yes, I agree, they are the equivalent of each other, except for the polarization. The polarization of the slot is at right angles, where the polarization of the dipole is in line with the dipole, where the polarization of the slot is at 90 degrees. And that's true. Otherwise, they radiate the same. But that doesn't explain why. That doesn't tell you why. None of the handbooks do. They quote this Jacques Bobnet principle, and it doesn't tell you anything. But they quote, every handbook quotes it, and it doesn't tell you absolutely anything. Here's what explains why a slot radiates at right angles. And this is what explained a slot antenna to me. Look at that antenna in the middle. Is that an antenna that you understand? Of course it is. It's a folded dipole, isn't it? Do you know what a folded dipole is? Of course you do. Every ham knows what a folded dipole is. It's a one wavelength loop of wire surrounding an open space. It's the same as a quad loop. Any of you ever have a cubical quad antenna? It's just a one wavelength loop of wire surrounding an open space. But look at the bottom antenna. That's a slot antenna. What's a slot antenna? It's a one wavelength loop of conductor surrounding an open space. All three of these antennas are basically the same. There's no basic difference between them physically. They all work exactly the same way, except that the slot antenna has to be fed in parallel, whereas the folded dipole or the quad antenna is usually fed by breaking the loop. Any place you want to, you can break it anywhere you want to and feed it. And it's usually fed in series. But it's difficult to series feed the slot, so it's fed in parallel. But if you wanted to, you can parallel feed a folded dipole if you want to. You could parallel feed a quad loop if you wanted to. And if you did, the polarization would follow you. If you shunt fed a folded dipole, it would be vertically polarized, just like the slot antenna is. This took all the mystery to me out of the slot antenna. It does everything a folded dipole does if you just shunt feed the folded dipole. So there is no mystery to why the slot antenna is vertically polarized if you shunt feed it that way. It would be the same way with a folded dipole. In fact, you can see it here. Here's the current that flows around the outside. And that's what does the radiating in a slot antenna. There's no current in the slot itself. The current is flowing around the outside edge of the slot, just like it is in the folded dipole. It's the current that flows around the outside of the space in the folded dipole that does the work, just as it is the current that flows around the outside edge of the slot that does the work. Yes, there's a little bit of current as you move away from the edge of the slot, but not much. Most of it occurs right at the edge, just as it does in a folded dipole. They are different antennas. Yes, of course they do. Of course they are. But the action is pretty much the same. And once I realized this, the slot antenna was no mystery to me. It's not the hole that radiates. The hole is the same as the hole in a folded dipole. The hole is the same in a quad loop. It doesn't do any radiating. It's the current that's flowing in the wire that's surrounding the folded dipole. It's the current that's flowing in the edge of the slot antenna that's doing the work. So that takes all the mystery out of the slot antenna. Well, here's the third mystery, the third discovery that I make. You can bend the slot and the plane to your heart's content and still get a perfectly good antenna. Here was one of the first bent slots that I built. What you're looking at here is the glass window of one of the sliding glass windows on my patio door. You can see outside. You can see you're looking from the inside of my house, looking outside to my patio. You can see part of the fence and some of the vegetation growing on my patio. So this is one of the sliding glass doors going out to my patio. And what you see here is a slot antenna made out of aluminum foil tape, taped onto the inside of my patio door. It was just a temporary. I didn't leave it there. I just put it up there for a test. But it's a bent slot. As you can see, it's 2-inch aluminum foil tape in an 18-inch square, and the slot is bent. So it's staggered. It's a staggered slot. And it's fed at the end. Now, one of the big differences between a slot antenna and a dipole is that the impedances along the slot antenna are inverted from a dipole. A dipole is low impedance in the middle, high impedance in the end, if you know your impedances along a dipole. A slot is absolutely reversed. A slot is high impedance in the middle, low impedance at the ends. It's exactly reversed from a dipole. That's the other difference between a slot and a dipole. Otherwise, they radiate identically with reversed polarization. So the feed points on a slot are near the end. In fact, there are two of them, between the center impedance, which is high, and the end impedance, which is low. So every slot antenna has two 50-ohm match impedances near the end. So between about 500 ohms in the middle and 0 ohms impedance at the end, there are two natural 50-ohm feed points near the ends of every slot. That's why the feed point shown here with the blue, where the blue SWR is shown here, is one of the feed points. There's another one at the other end. I could have put it over at the other side. So you feed a slot antenna in parallel at the end by simply jumpering your cable across the slot where you see the SWR marking there. And you adjust the SWR of a slot antenna simply by moving the feed point. It's very easy to adjust the SWR of a slot by simply moving that feed point. Just below that feed point, you see a little ballon. That's just a ballon, a little coax ballon that I use there to match it. You adjust the tuning of the slot by using a shorting tape at the other end. That's just a piece of aluminum tape stuck across the other end. Slot is very easy to tune. You just move the feed point for SWR, and you move the shorting tape at the other end to do the tuning. And that's what you do for all slot antennas for tuning. Very easy to tune. Now, you could make this straight if you want to, or you don't have to make that many staggers. But this is an excellent little antenna You can tape it onto an upstairs window or something if you've got a 2-story house facing a repeater, and you've got an excellent little 18 by 18 inch aluminum foil tape on glass antenna. Excellent little project. I've made slot antennas with aluminum foil tape on trash cans and all sorts of things. They're just easy antennas to make. Now here's one that won me an antenna competition that ran in QST in March 2018. And again, you can get this article from my website, w6nbc.com/articles, and you can download this article from March 8, 2018, or you can go to the ARRL website and download the article from the article archives. QST March 2018. I won a competition, the antenna design competition for this one. This is an antenna that's excellent if you've got a motor home, be it a metal motor home or a fiberglass motor home. Works well for either of them. It's a completely ground independent antenna, but the ground plane for the slot is folded. I've folded over the ground plane, which is two metal squares. So that's the ground plane, and the slot is the space between them. And it's fed there over at the side, as you can see, with a little movable stub there, which slides back and forth, so you can adjust how much the coupling is. And this one is held onto the top of my pickup truck here. And the slot is the actual gap there between the two metal posts at the right and the left. The other two posts are fiberglass, just to hold the two metal planes up. So this is a folded plane slot. Works very effectively. The whole thing is held onto the top of my pickup truck by some cup magnets. There are 4 cup magnets. You can see them under the metal post there. I've had this on top of my pickup truck when the freeway was very clear. I took it up to 100 miles an hour and it stuck on just like glue, so it didn't come off. You can find this article there if you want to make one of these. You can mount one on top of your motorhome because it's ground independent. You can put it on metal surface or you can put it on a fiberglass surface, and it works just as well. It's a great little slot antenna for a motorhome or the top of a pickup truck, or it goes anywhere. It's a great slot antenna. Fourth discovery: the plane of the slot can be very narrow. I pointed out it can be wide, but it can also be very narrow, and it becomes what's called a skeleton slot. And I learned about the skeleton slot from an antenna that's quite popular on the internet called the hentenna. The hentenna was developed by a couple of Japanese engineers back in the 1970s or 80s, I forget when exact, and they developed it for 6 meters. It's quite popular 6-meter antenna because it's a vertical slot, which has all the properties of a vertical, and yet it's horizontally polarized, which of course all slots are. The polarization is rotated. And you can see it here. This is the basic design that the 2 Japanese engineers developed. It's about a half a wavelength long and about a 1/6 of a wavelength wide. This was their general recommendation, and it's approximately the right shape for the best bandwidth. And it's fed about a 1/10 of a wavelength from one end. Of course, it can be fed from either end, as I pointed out, because that's where the low impedance points are. And you can see the basic design. It builds very nicely out of 1/2-inch copper tubing. And as you can see it here, here's a hentenna. This is called a skeleton slot because the slot is just a skeleton. There's very little left of the ground plane, and most of the slot is a big open space. But as I pointed out, the open space, it's really a folded dipole shunt fed. It's just a shunt fed open folded dipole. As I pointed out, a slot is a folded dipole. That's all. Shunt fed. That's all. Here's another little skeleton slot or shunt fed folded dipole that I ran an article on, which you can find in QST January 2019. I called it the slot cube. Now you can take the slot, the skeleton slot, and fold it up in the form of a cube. As you can see it here, you can see that it's really a antenna folded up as in the form of a cube. And now you've got an 11-inch cube, and you can see the shunt feed there on it, which is made with a piece of CPVC. And by the way, CPVC it fits copper tubing. It's made to fit copper tubing. And that article ran in QST January 2019. It's a folded skeleton slot, and you can see the little ballon made of 6 turns of RG Mini 8U there, and it's a little 1/4-inch gap there in between the copper tubing, which is the shunt feed on it. This is a little 11-inch cube made of 1/2-inch copper pipe on 2 meters. That's a tiny little antenna, yet that antenna has the same gain as a J-pole. Which one of those antennas is a neighbor going to notice? A big 6-foot-tall J-pole sitting on top of your house, or this antenna sitting on top of your house? Yet both of them have identically the same gain, and they're both vertically polarized. I don't think it takes much figure out which one of these antennas your neighbor's going to notice. Same gain. And you can see how this antenna is a devolution of a antenna. It's a folded up 2-meter antenna, folded up into a cube, the folded slot cube. It's only 24% the size, a 25-inch 2-meter antenna. Great little antenna. I've won a cover plaque award for this one. This is showing you it being folded up into a cube. That's how it works. This is the best feedback I ever got from a reader. He made one of these and he was so happy with me. He sent this picture of himself. I don't think he's K9 IBT anymore, but anyway, he was so happy with his slot cube antenna that he sent me a copy of it along with my article. This shows you, this is a J-pole antenna in red, and this is the 2-meter slot cube, which is only quite small, as you can see. And here are the gain figures showing you an easy neck and showing you the little antenna, and it's gained 5 megahertz bandwidth. You can see there's very little reason to use a J-pole with this little antenna. It's perfectly equal to a J-pole, but a heck of a lot smaller. Your neighbors will thank you for making one of these. 5th discovery. This is an important discovery. If you don't learn anything from this presentation, and it has nothing to do with slots, but it's applicable to slots, learn this one. This is a valuable lesson. All parts of an antenna do not radiate. Now, if you stand up in a radio club and you ask this question, what parts of an antenna radiate? Most people will say, well, all of it, don't they? No, all parts of antennas do not radiate. Why do I say that? Let me prove it to you. Here's the infamous copper pipe J-pole. What ham hasn't built a copper pipe J-pole for 2 meters? Here's one that sat on top of my house for a long time until I built a slot cube. Here's a representation on the right. Where is it from? It's from EasyNet. And by the way, if any of you have like to do antenna modeling and have not got a free copy of the professional version of EasyNet, which is now available free from easynet.com, be sure to get yourself a copy because it's all free since Roy Llewellyn retired and made the professional version of EasyNet free on easynet.com. So go get yourself a free copy if you haven't got it. No use. You used to have to pay $350 to get the professional version. It's now free. So anyway, in EasyNet, there's a feature in it where you can show the current flowing in the various parts of your antenna. You just turn on this feature, and this is the current display feature in EasyNEC. It's an EasyNEC model of a J-pole, which you could easily get off the internet. If not, I'll send you a copy of it if you just send me an email. This is an EasyNEC model of the copper pipe tip of the famous copper pipe J-pole with the antenna currents turned on. The antenna currents and the antenna current phase. In other words, what the phase of the current is. The amount of the current in any portion of the dipole is in the antenna is shown by the purple line, and by how far the amount of the current is shown by how far away the purple line is away from the antenna model. So as you can see there in the top of the antenna, the current is strongest in the middle of the dipole and weak at the end. There's no current essentially at the ends. So the top of the dipole radiates most strongly from the middle. And in the bottom, the U section of the J-pole, there's very little current at the end of the U section and a lot of current at the bottom. But notice the phase of the current, which is the direction the purple line is away from the model. Notice that in the bottom section that the phase is opposite in the bottom, which means that in the bottom of the J-pole, the currents are equal and opposite, which means that in the bottom of a J-pole, the currents are opposing each other. What happens when currents are equal and opposing? They cancel. It means the bottom of a J-pole does not radiate. There is no radiation coming off of the bottom of your J-pole. The bottom of a J-pole is only a matching section to match the 50 ohm impedance of the feed point to the top section. Only the top of a J-pole radiates. That's all. The only place that RF is coming off of a J-pole is in the top section. And EasyNEC easily demonstrates that, because that's the only place in a J-pole where the current is unopposed. Therefore, don't think that the bottom of your J-pole is making any radiation. It's not. It's only a matching section. It's a matching transformer. The top of your J-pole is what's doing the radiate. That's why whenever I design an antenna, I always model it in EasyNEC. I always turn on the current amplitude and phase in EasyNEC. I always look at the current amplitude and phase, and I always see what parts of the antenna are radiating. It's very meaningful in knowing what your antenna is doing. And if you haven't learned to do antenna modeling with EasyNEC or with 4NEC2 or any of the other modeling programs, if you like building and designing antennas or modifying antennas, you owe it to yourself to learn to do antenna modeling. I know EasyNEC. I don't know 4NEC2. I don't know the one that the ARRL recommends, so I stay with EasyNEC. And now that it's free, I stay with it exclusively, but that's just my preference. All of the discoveries here that I've showed you combined now led me to slots for the HF bands. And the one I'm most proud of is the antenna I call the double delta slot vertical. It's a horizontally polarized antenna. Why do I like horizontally polarized antennas? Because they're low noise antennas. Vertically polarized antennas tend to be noisy. But it's a low angle radiation antenna. Horizontals tend to be high angle radiation antennas. But this one is a low angle radiator, which is typically what verticals are. So this is an antenna that is a vertical antenna, but it's horizontally polarized. Where have you heard of a vertical antenna that's horizontally polarized? Well, this slot antenna is. It's a horizontally polarized vertical antenna with a low radiation angle. That's almost a misnomer, isn't it? But this antenna is. and it has elevated radiation. The radiation comes off the top of the antenna, not off of the bottom of the antenna like most verticals. Here's the antenna. This is the inverted delta skeleton slot antenna. This is the antenna I'm most proud of. And it can be done as a double crossed, and this is the way I like to use it most. Double inverted delta skeleton slot vertical. It's horizontally polarized, but like a vertical, because it is a vertical, it has low radiation angle and it has elevated radiation for better ground loss. And it has azimuth gain, which where have you ever heard of a vertical having azimuth gain? Here's the gain of this antenna on 10 meters, 20 meters, 40 meters, and 80 meters. And here's the outer ring. This is 5 dBi. It's absolute gain. On 10 meters, this antenna has nearly 9 dB gain for a vertical. Here it is in my backyard. See what it looks like. Interestingly, even my homeowners association doesn't notice it. It's been up for well over a year, and my homeowners association has never taken notice of it because they don't know what it is. It doesn't look like an antenna, although the pigeons love it. And unfortunately, the pigeons do their duty. It has no guys. It uses a 4-foot soil pipe to hold it up. No concrete, by the way. You don't need concrete to hold up a soil pipe. But it uses a base auto tuner. It does need a base auto tuner to work. At the top, it has a 3D printed hub, although you can make one out of materials yourself. You can hand make the central hub. It uses fiberglass arms to hold up the wire, which make up the deltas, the 2 deltas. But I printed it because I am a 3D printer. I have a Prusa Mark IV 3D printer, and this was printed. If you want the printing model, I'll send it to you. All you have to do is send me an email. My email address will show you at the end here, which you can get by just downloading these files from W6NBC.com /slides, made with number 14 wire and some 4-foot fiberglass spreader arms from DX Engineering. All this material is readily available. And this is DX Engineering or aluminum pole. Here's what it looks like. Collapses to 6 feet. Easy one-man lift. This is a telescopic poles. I'll show you where they come from here in a minute. Here's the tuner, which I use at the base. This happens to be an LDG tuner. This is a tuner and a little switch box relay here, which I'll show you here in a minute. So 6-foot nesting aluminum tubing, which all came from DX Engineering. 4.5-inch 4-foot fiberglass spreaders. They also came from DX Engineering. 5 stainless hose clamps, which allow these 6-foot nesting sections to from 1 3/8 to 2 inches to be slid up, and then the hose clamps hold them up. And my little slot antenna handbook, you can also get that one if you want. And there's the QR code to get to it. And that's basically it. You can get all of this information that I'm showing you here. It's all available for download, W6NBC.com. Just put /slides on the end and you'll get all the slides and information.
Great. Great job, John. Thank you so much. That was really interesting. I always learn something new every time I see these. So I want to ask a quick question here first. You talked about the zigzag of a J-pole canceling each other out at the bottom half in terms of the currents being opposite polarity. But yet you had a zigzag aluminum foil pattern on your window that was zigzagging back and forth. So, and you said that that worked just fine. So how do you reconcile those two things? I'm not clear.
Well, I'd have to go. I have to go quite a bit to explain that, but it definitely no problem there. I'm sorry. That's a pretty lengthy one to
Okay.
answer that one. But that little staggered slot works just fine.
And the total length or the wavelength that you're tuning to is the total length of that zigzag slot.
2 meters, 39 inches, 40 inches long. The total length of the zigzag is 40
Yeah,
about
half wavelength.
a quarter. Yeah, half wavelength.
Right.
Slots are all half wavelength long.
Right. So my other question was, can you build a HF slot antenna out of ladder line?
Sure, why not?
Would the material in between the dielectric, would that interfere with anything, or would
No.
it change?
It would just shorten the slot some.
Oh, it would shorten the slots.
Yeah, just shorten the slot some.
Interesting.
Well,
All right.
yeah, it would just
So
just shorten the slot.
So it's Q&A time. So let's open it up for a question. You can either raise your hand physically, or you can click on the reactions icon below and you raise your hand with an icon. So Dan's got a question. Go ahead, Dan.
Well, I'd just like to follow up on that zigzag antenna on the glass. The polarization obviously has to be some kind of combination, I would think, of vertical and horizontal, because of the fact that the slots are both horizontal and vertical. Is that correct or not?
No, actually, that antenna is vertically polarized. Again, to answer that one, it takes some doing, but take my word for it. That antenna is vertically polarized.
Okay, and another question was on that cube antenna that you had. Obviously, there was no ability to tune that thing based upon the fact that all the pipes were all soldered together. Did you have to figure that out beforehand building it, or?
Well, first of all, it has quite a bit of bandwidth, so it has a nice. It is quite broad in bandwidth. But if you want to tune it, you just have to do a little unsoldering and resoldering. But or one of the ways people have tuned it, if you need to tune it, is to go opposite the corner that comes together where everything is, where it's mounted. And on the other pod, you put some little stubs down from the top to the bottom on just the diagonal corner, and they can be trimmed, and you'll find you can tune that antenna quite well that way.
Thank you.
Craig, you've got a question there. Go ahead, Craig.
Thank you very much. Well, first off, I've been throwing some comments in the chat. I assume you saw that going back to your dish design in the first place. I had to go to the minutia in the FCC regs, which says that there's no limit on legal dish size for TVRO in Alaska. So I've got a friend, Mike Nolan, who has a moon dot station, and every now and then he hooks his television set to it, and lo and behold, it's now a TVRO antenna that's totally legal. So then the neighbors have something to say about that. So, you don't let the door bang in the rear end on the way out. That goes back to Representative Ted Stevens, and it's a long and interesting story. I'll tell you sometime. Other thing, I do a lot of satellite activity, and one of the other comments I put on was that radiation pattern.
You're breaking up, Craig.
Yeah, we've got you froze right now on the screen, Craig. So
as compared to a lot of vertical antennas. Okay.
yeah, we
Take
lost the
somebody
last
else.
half of you there, Craig. In fact, actually, your video is definitely froze, and your audio went out on us on the last there.
Craig, you might want to try just putting your comments into the chat like
Yeah,
you did
sorry
before.
about that. That's internet in Peru. Okay, if I stop the video, is that any better?
Yeah, we've got sound on you now, so that sounds much better. It
Right.
was probably eating up your bandwidth.
Yeah, it's bandwidth from Peru. Yeah, I don't know. Have to raise some more monies at Sherry for the chicken ranch or something. Okay, Sally, I like the vertical radiation pattern of the cube compared to a lot of the other vertical antennas on VHF for satellite use. I'm going to experiment with that because the Lindenblad with the four canted dipoles is typically best antenna that you can use. Have you tried your cube antenna with satellites?
No, I haven't. I haven't done a lot of satellite work. I've certainly worked I made a number of contacts, but it's been more just to experience it, not to really get into it.
Okay, on the HF antenna, the last one you showed, can you change the gain by switching in different sections? Can you emphasize gain in one direction or the other based on switching?
Well, I didn't cover it. You can change the directivity of that pair of two loops crossed by switching the phase of one of them with a double pole double throw relay. That way you can turn the pattern by 90 degrees. So I do that too, but I didn't have the time to cover that entirely.
So I think Dan had a question.
Is that why TV and TV broadcasters use the slot antenna, because they can have horizontal polarization as well as low angle? Is that the whole reason?
Yes, of course.
And why do they do horizontal polarization in the first place? Can you explain that?
Yes, I can answer that one. It goes back to the history of things. When by the time the television came out, VHF was already being used extensively for mobile cars, police cars, taxi cabs, dump trucks and other things like that. It was in wide use. VHF was in wide use for mobile radio. And that was all involved vertical whip antennas on cars, police cars and so forth. And it was thought that if television came out, it would be better since they were largely on the same frequencies. Because when television came out, it was all in low VHF, like police cars and everybody else was in low VHF too. It was thought that the two would interfere with each other. So the idea was, let's make television horizontally polarized. Therefore, they would interfere with each other less. And so that's what the FCC adopted as the polarization for broadcast television, because of the potential for interfering less with land mobile two-way radio. And it was adopted that back at that time for that reason. Same was true in the UK. They did the same thing.
Yeah,
Frank's got a
Frank, go
question.
ahead. You've got the floor. Frank, you look like you're unmuted, but your sound is not coming through. Okay, sorry about that. Mic not working. I understand technical difficulties. I should have a little sign that comes up and says that. Yeah.
If you figure it out, feel free to raise your hand again, Frank.
Yeah.
So who else has a question or a comment?
Well, Rudy, you have done another perfect one here with John as your special guest. We are at the top of the hour, so you've hit it on the nose, Mr. Wiedemann.
All right. Well, if there are no other questions or comments before we close, then I want to thank John for sharing his time and his wisdom with us. I think this is really a pretty interesting topic. And I think it's something for us all to go to John's website, which is W6NBC.com, explore that, buy his book off of Amazon like I did, and read his articles in QST. And I think this is some people call the slot antenna the yin of the dipole yang. It's kind of the interlocking kind of a concept of antenna. So with that, I'll bid you all adieu. Thanks again, John, for everything, and we'll be in touch.
Very
All the
good.
best.
Thank you, everybody. And thanks again, John, and everybody for attending. Look for the flyer for next month, and we'll see what Rudy brings to us, the Antenna Whisperer. So that's it for this evening. That's it for TennaTalk in August. Everybody have a great week. Bye-bye.
Bye-bye.